So today we are going to continue to work on proofs. The more practice you get, the better you get at them. So I would highly suggest that you have in front of you your proof practice packet. We're going to do a couple of proofs out of there. Your composition notebook, because you're going to want to write down the last 3 proofs that we're doing today. And then also your proofs reason reference sheet. So all 3 of those things should be in front of you right now. So pause the video and get those. All right, so let's start with, we're going to do some pre-proof practice. I'm going to look at proofs that have pictures today. So one of the things I like to do is some pre-proof planning. So look at what you've been given. E is the midpoint of AC. Well, here's AC from here to here. I'm going to move this over. Oops, I don't know why that did that. I just want to move it over a smidge. There we go. So E right here is the midpoint of AC. So this is a line segment. If E is the midpoint of AC, I can make so here's what I'm looking at, just this right here. I can make a conclusion that segment AE is congruent to segment EC. So AE is equal to EC. Then if I also have that E is the midpoint of BC, so then right here, this part that E is the midpoint of BC, so here, oh, we have to make a correction because that's not right. We don't want BC, we want BD. So please correct this to read BD because we want to go from B to D. We don't want to go from here to here. So from B to D. All right, so if E is the midpoint of that, then we can conclude that DE is congruent to EB. So from here, DE, and I'm going to use ED instead of saying DE, because notice here in our proof we already have ED. So I want to use the same notation that they're using here as well. So instead of saying DE, I want to use ED. So ED is equal to EB. And again, instead of EB, I want to use BE because that's what they're using over here. So we want to always try to use the same notation as may already be in our proof, because it does make a difference. So those are the conclusions I can make from the midpoint. And then they give you this little tidbit, if you will, right here. Also, line segment ED, so I'm going to put like triple tick marks here. Line segment ED is congruent to line segment EC. So we have that extra little tidbit. So if these 2 are congruent, and these 2 are congruent, and these 2 are congruent, logic reasoning states that these must be congruent, which is what we're trying to prove. However, we can't use logic reasoning as a reason. So we're going to have to use some other way to get there. So let's start with what we know for sure, and that's our first statement. So our first statement is going to be our given. So E is the midpoint of AC and, I'll squeeze that in here, BD. So remember we changed that because it was written wrong. And then I'm also going to put that extra little tidbit, and they also gave us in the given that line segment ED was congruent to line segment EC. So that's our given. Then from there in our pre-proof planning, we noted that if E is the midpoint of these 2 segments, then we could conclude these items here. However, notice that this little tidbit is in congruency notation, And then our proof statement is also in congruency notation. And according to the definition of a midpoint, which is why we were able to conclude these two items, if you look at your reasons for proofs reference sheet, the definition of a midpoint uses equality notation, whereas the midpoint theorem uses congruency notation. So if you want to skip a step, save a step, I am going to switch these here in my pre-proof planning to read congruency, and then over here a congruency, because that way I can use the midpoint theorem instead of the midpoint definition and save a step. It's picky but true. All right, so then step 2 is going to be your conclusion from step 1, which is that segment AE is exactly congruent to segment EC and segment ED is exactly congruent to segment BE. And our reason for that, I explain why I'm going to use a midpoint theorem versus the definition. So midpoint theorem. Okay, then 3. So from here, we have to look at what we've been given. So we know that ED is exactly equal to EC. Well, we have EC here and here. Doesn't that mean that I could, and I'm trying to get to this statement here. So if EC is equal to this, then couldn't I replace EC here with ED, right? So I could say AE is congruent to ED just by substitution here. And if I did that, then I would have ED here and here, and I could put the AE and the BE together. So let's try that. That's a substitution. So I am going to substitute in, and I'm putting this in pink because it's not really part of my proof, but I want you to see what I'm doing. I'm replacing or substituting in ED right here in for EC. The reason why I'm doing that is because I want to keep AE because it's part of my proof statement, and I need to get rid of this EC. Well, replacing it with ED isn't necessarily a help in that respect, but I notice that there's an ED over here, which then I'll be able to do something with here in a minute. So let's go ahead and do that substitution. So AE is congruent to ED, segment ED, and our reason for that is substitution. Prop of equality. Okay, then now that I have, so we're going to ignore this one here for right now. So we're going to use this statement here, AE equals ED, and this statement here. If AE is congruent to ED and ED is congruent to BE, then can't we say that AE is congruent to BE? Now the problem is we start with ED because this statement 2 comes first. So we really are starting here. ED is equal to BE. Notice that we do not start our next statement with what we ended up with here. We start with AE equals ED. So you might want to say that this is a transitive property or the law of syllogism, but it doesn't follow that pattern. But I could substitute in BE for ED here. So this is just another substitution because it doesn't follow the transitive property of the law of syllogism. I'm just substituting in BE into this congruency statement with an equivalent value. Since ED is congruent to BE, I can substitute it in here, and now that's going to equal my proof statement. So step 4, I can state that AE is congruent to BE by the substitution property. of equality. Okay, so then we are going to skip 12 and 13, and we're going to go on to the next page and do 14 and 15. Okay, so we're going to look at 14 and 15 on this page. We do have a bit of a correction to make before we start. So if you will scratch this out, it should go down here. Segment NO is congruent to segment OC. There's a little correction there. Okay, so let's do some pre-proof planning. And we see here that O is the midpoint of NW. So here's N to W, right? And there's O. So, and then we also have this little tidbit that segment NO is congruent to segment OC. So I'm going to state those. Since O is a midpoint of NW, remember we should be able to conclude if and only if, based upon all of our work with the midpoint so far, and we just did one that had a midpoint, right? On number 11, right? So then if O is a midpoint of NW, we can conclude that NO is congruent, because they're using all congruencies down here, so we're going to use congruencies as well, is congruent to not WO but OW, because that is what is being used in the proof statement right here. So I used NO because that was what was being used here, and I used OW because that was what was being used here. And so these are your segments right here that are equal based upon this statement here. So here O is the midpoint of NW, so then those two pieces must be equal. Then you were given this extra little tidbit right here that segment NO is congruent to OC, so I'm going to put a little double tick mark there in green and a double tick mark there in green there. Well, logic reasoning states that if these two are congruent and those two are congruent, so then those two should be congruent. But notice the progression of the proof here. You can't just say, well, logic reasoning, right? So I want you to pause the video at this point, and I want you to come up with the reasons and then this missing statement right here, and then restart the video. So please, please, please do this on your own. Something is better than nothing. Failure leads to success, right? So pause the video. Okay, so hopefully you actually pause the video. All right, so 100% of the time, your very first reason is given, which is exactly where we got O is the midpoint of NW. And based upon our pre-proof planning, shouldn't this be the missing statement that goes right here? So that is going to be our missing statement. NO is congruent to OW. And same reason as I explained in the previous proof. Normally I would be using the definition of a midpoint here, but because we have a congruency statement, we are going to be using the midpoint theorem. Whoops. Okay, then this was given, right? And so now to go from 2 to 3 to 4, notice the pattern. NO is congruent to OW. We start with NO again is congruent to OC. What we ended up with here is not what we started with. So we cannot use the law of syllogism or the transitive property to get to here. But notice that in statement 2 and statement 4, the OW is in the same place. All we did was take NO right here and replace it with OC because that's what it equals. And that is substitution. So then this is the substitution property. Of equality. So oftentimes if you think it's the transitive property or the law of syllogism, but it doesn't follow the pattern, it is a substitution property. Okay, so then let's do number 15. And for number 15, we do have a slight correction. Down here at statement number 6, add a tilde right there to make it a proper congruent statement. So then what I want you to do, you have all the statements. I want you to try to pause the video and see if you can figure out what they're doing here to get, and then what are the reasons for that. Notice you're only given that EF is congruent to GH. So EF is congruent to GH. That's your only given. And it's hard to make a conclusion there, so you have to kind of look at the picture and make a conclusion with a picture. It seems obvious that if these two are congruent, then the distance from E to G would be congruent to the distance from F to H because they have this FG in common, which is the key to the whole proof. So pause, do all the reasons on your own, and then restart. Okay, so hopefully you got that the very first reason is given, which it is. Then note that from statement 1 to statement 2, it's a change in notation. Remember, when we have that change in notation, we're going from congruency to equality. We say that congruent segments have equal measure or measures. I'm going to squeeze it in here. Right? Okay. So then from the second statement to the third statement, notice that E and F are still on the left side, and GH, or EF and EF are still on the left side, and GH and GH are still on the right side. The only thing that's different between statement 2 and 3 is that we are adding this FG to both sides. That's it. We're just adding FG to both sides. So if we're adding something to both sides, isn't that the addition property of equality? Then we come to a different statement. We have the distance from E to F plus the distance from F to G is EG. So notice we have this statement right here, right, is the same as this one here, but that's EG. Look at the picture. EF plus FG is equal to E to G. Isn't that the two smaller segments add up to the whole bigger segment? That sounds like the segment addition postulate. Does this follow the same thing? Are these the two smaller segments that add up to FH? Well, let's see. GH plus FG, doesn't that equal FH? It sure does. So that is our segment addition postulate. Okay, then we're going to do a thing here. So notice that on this side in equation 3, we have this. So we are replacing EF plus FG with what its value is, EG. And then over here on the right side, we were replacing its value here with FH. So EG went to replace here, and FH went to replace here. And so we just have EG is equal to FH. And so that is purely substitution. And then finally, we have a change in notation. We're going from equality to congruency. So it's really the converse of this reason number 2 up here. So segments with equal measure equal measures are congruent. So if you did that all on your own, congratulations. All right, now the last 3 that we're going to do, you'll need to write down yourself. So here we go. So in your composition notebook, if you would please pause the video and write down everything that you see here, including the 2 columns. And then this is what you're going to do in your homework, because I did not print off your homework, and your homework has a lot of partial proofs and full proofs. for everything you need to print out, you need to write down the entire thing unless you're going to print off the homework and then you can write on it. But if you're not printing off the homework, you have to write down everything, not just the missing parts. Okay, so hopefully you pause the video to write this down. So we're going to go through this again. We're going to do a little pre-proof practice here. So if I'm given that angle 1 and 2 form a linear pair, which you see right here, you should be thinking, what do you know about a linear pair? So look at your reasons for proofs reference sheet, and your conclusion from this is that the measure of angle 1 plus the measure of angle 2 should add up to 180 degrees. It's important that we get that in there, because if they form a linear pair, the conclusion is their sum is 180 degrees. And I'm purposely using the measure of angle 1 here because we have the measure of angle 1 notation in our proof statement. And then please note that in your picture, we know that the measure of angle 1 is this and the measure of angle 2 is that. So you have to get these values for each of those angles into the statement column as well. Since it's part of the given, we are going to attach it to this given statement. You cannot use these if they're not in your statements down here. Okay, so our very first statement is going to be angle 1. Ignore that.
It's time for lunch.
And angle 2 form a linear pair. Squeezing that in there. Okay. And I'm going to add in the measure of angle 1 is equal to 2x minus 11, and the measure of angle 2 is equal to x minus 4. And that way we have brought in what's in the picture into our statements and we can use it in the proof. So reason 1 is given. All right, so then from there, remember from here, we have a linear pair. We want to go to this conclusion. So that's our second statement, is that the measure of angle 1, and we cannot say, we can't go on this statement, 2x minus 11 plus x minus 4 equals 180, because we haven't stated this yet. The conclusion to they form a linear pair is not that these add up to 180, it's that the measure of angle 1 plus the measure of angle 2 adds up to 180. Then we'll sub in what we know the measure of angle 1 is and what the measure of angle 2 is. So, whoops. So the measure of angle 1 plus, and remember I'm specifically using the measure of angle 1 because that's in my proof statement. And our reason for that is definition of a linear pair. Okay, so then from here, I can go ahead and substitute in the values we have for angle 1 and angle 2. So I'm going to substitute in for the measure of angle 1, 2x minus 11, plus, and for angle 2, x minus 4 equals 180. And then our reason for that is substitution. Okay, and then our next statement from here, for the most part, and this is a smidge of a longer proof because of what we have to do at the end, but for the most part it's just math from here on out. So our next step would be to collect like terms, which you can use as a reason. So we're going to collect the 2x and the x, and the negative 11 and the negative 4. So 2x and x is 3x, negative 11 and negative 4 is negative 15 equals 180. And you have two options here for your reasons. You can either say collect like terms, or you can just say simplify. because that's what we did. So either of those two reasons are acceptable here. And then step 5, the next thing that we would do would be to add the 15 to both sides to isolate the 3x. So in a proof, we don't show what we're doing to both sides, we just show the result. So the result would be 3x equals 195, and we did that by the addition, because we added 15 to both sides. So addition, prop of equality. Okay. Then we are going to divide both sides by 3 to solve for x. So we get x equals 65. Our reason, division property. Of equality. All right, so the problem here is our proof statement is not x equals 65. It's the measure of angle 1 is equal to 119. So we know that the measure, and I'm going to circle this, we know that the measure of angle 1 is equal to 2x minus 11. So I'm just going to take this here and write it as my 7th statement, but instead of x, I'm going to substitute in 65, because that's what you would do if you were solving this algebraically. So that's what we are going to do. So statement 7, the measure of angle 1, and notice that me putting in the measure of angle 1 gets the measure of angle 1 into my proof statement. So that's one reason why I wrote it that way originally. So measure of angle 1 is equal to 2 times 65 minus 11. And our reason for that is just substitution. Okay, and then finally, you're going to simplify all that, and lo and behold, you get the measure of angle 1 is indeed equal to 119. And your answer to that is just simplify. We're not collecting like terms this time, so you can't use that as a reason. We are purely just simplifying 2 times 65 and then minus 11. And then you are done. All right, let's look at the next one. So on this one, it is very, very similar to one that we did before, and actually 2 that we've done before. So I want you to do some pre-proof planning. You're going to go ahead and pause the video. You're going to write all this out, and then restart the video. So start there. Just write this first into your composition notebook, and then restart it, and we'll talk about the proof planning. Okay, so hopefully you wrote this down. So given that A is the midpoint of ZP, line segment ZP, and then we have the line segment over here, isn't our conclusion that ZA is congruent to AP? And our job is to prove that x equals 6. So from here, if I've got a midpoint, I can conclude that I have equal segments. It doesn't matter whether you use congruency or equality this time, because it's not going to, it doesn't show up in our proof statement. So I like to use my definition of a midpoint, so I'm going to use that. So at this point, I want you to pause the video, try to do all the statements and reasons on your own, and then restart the video and see how you did. All right, so your first statement should have been A is the midpoint of segment ZP. And that's a line above that. And then your reason is given. And then I also want to put in here, just like we did in our previous proof, notice that this is in our given statement. So I want to note that the distance from Z to A is equal to 2x plus 1, and the distance from A to P is x plus 7. So if you didn't and you forgot to include that, you need to. So, and, put the word and in here, and ZA is equal to 2x plus 1, and AP, distance from A to P, is equal to x plus 7. So now that's all from our given. So then statement 2, our conclusion from A as the midpoint is that ZA is equal to AP. You cannot put 2x plus 1 equals x plus 7 in statement number 2. You have to have this statement first. And so our reason for this is definition of a midpoint. You could have, if you used a congruency statement, you could have used the midpoint theorem. Okay. Now I can substitute in what ZA is, which is 2x plus 1, and AP is x plus 7. And then our reason is substitution. Okay. Then we're going to solve this step by step. So the first thing that you should do is focus on your variable terms. So we're going to subtract this x from both sides, and our result would be x plus 1 equals 7. You cannot do more than one step at a time. So that is the subtraction property. Of equality. And then finally, wouldn't we subtract 1 from both sides, and we would end up with x equals 6, which is our proof statement, so perfect. And again, that is the subtraction property of equality. Okay, and then we have one last proof to do. So for this proof, go ahead and pause the video and write down everything that you see, and then we will talk about some pre-proof planning. Okay, so hopefully you pause the video. Now, this time we're dealing with angles. So you've been given that ray BD bisects the angle ABC. So if that's the case, then I know that this angle is congruent to this angle. And I am trying to prove that x equals 8. So if that bisects it, then I know that the measure of angle ABD is equal to the measure of angle DBC by the definition of an angle bisector. And then from there, won't I substitute these values into here, solve it algebraically? Don't forget, you want to get this included into your given in that first statement. So go ahead and pause the video, do the entire proof on your own, and then restart the video and see how you did. Okay, so statement number 1 should be ray BD bisects angle ABC. And I'm going to put in there that the measure of angle ABD is equal to 5x plus 7. And the measure of angle DBC is equal to 3x plus 23, squeezing that in there. So step 1 given. All right, so you want to make sure that you got this part in there. All right, so then step 2 is our conclusion from step 1 that the measure of angle ABD is exactly equal to the measure of angle DBC. Your reason is definition of angle bisector. Okay. Then step 3, we can substitute in the values of the angles. So 5x plus 7 is equal to 3x plus 23. And that is substitution Okay. And then from here on out, it's just your math. So you want to focus on your variables first. So we're going to subtract 3x from both sides first. So I would end up with 2x plus 7 is equal to 23. And that is going to give me, or we subtracted 3x, so that's subtraction property of equality. Okay, then you're going to subtract 7 from both sides. So again, the subtraction property. And that's going to equal 16. Okay, and then finally, we get to 6, where you divide both sides by 2, and you do get your proof statement of x equals 8. And so that is the division property of equality. All right, so now you are working on your homework. If you have questions, please don't hesitate to ask. Good luck.